Hello all, welcome to Apex. I am Deepak Nemani, your LRDA mentor at Apex, and in this video I will be discussing basic concepts of clocks, and I will also be solving different models of questions that can be expected from clocks. So without any further delay, let's get started. So I consider clocks to be an extension of speed, time and distance. And what is the relation between speed, time and distance? We know that distance is equal to speed into time, right? And in general, distance will be measured in kilometers when speed is mentioned in kilometers per hour and time in hours, right? And distance can also be mentioned in meters when speed is in meters per second and time is in seconds, right? In clocks, we will be measuring the distance in terms of degrees, speed in degrees per minute and time in minutes, right? And generally when I talk about clocks, in general we have two types of clocks, analog clocks and digital clocks, right? So in this session we'll be mainly focusing on analog clocks, and in general in any analog clock you'll be having three types of hands: hour hand, minute hand and seconds hand. But in this session we'll only be considering hour hand and minute hand, right? So in this clock, this shorter hand is known as hour hand and this longer hand is known as minutes hand, right? The shorter hand is hour hand and the longer hand is minutes hand, right? And you won't be given with the speeds of hour hand and minutes hand in any question, and they will be having some speeds because the position of hands in the clock won't be stationary, right? They will be moving, right? So they will be moving with some uniform speed, right? Now let's try determining the speeds of hour hand and minute hand. Now let's determine the speed of minute hand first, right? Now for example, let me consider both the hands are at 12 o'clock. Okay, so hour hand is at 12 and minutes hand is also at 12, right? Now when will this minute hand, the longer hand, will be at 12 again? After 1 hour. Okay, at 1 o'clock, okay, this hand will be again at 12. So in this 1 hour, it has covered a total of 360 degrees. So because one complete rotation is 360 degrees. Okay, so it has traveled 360 degrees in how many minutes? 1 hour means 60 minutes. So 360 degrees by 60. This is nothing but 6 degrees per minute. Now this is the speed of minutes hand, right? Now coming to speed of hour hand. Now let us consider the before scenario when both the hands are exactly at 12. Now when will this shorter hand, the hour hand, will be at 12 again? After 12 hours, right? Okay, if this hand is at exactly coinciding with 12 at 12 a.m., it will be again coinciding with 12 at 12 p.m. That means after 12 hours. So this hour hand will be traveling a distance of 360 degrees. That means it will be completing one rotation in 12 hours. So 12 hours, let me convert that to minutes, right? So 360 by 12 into 60, because we have 60 minutes per hour. So 12 into 60. So this is nothing but 6 by 12, half degree per minute, right? So the speed of hour hand will be half degree per minute, right? Now if you observe, both the hands of a clock will be moving in same direction, right? Clockwise direction, and minutes hand is having greater speed compared to hour hand. Now let us determine the relative speed of minutes hand with respect to hour hand, right? Now when we have two objects moving with speeds s1 and s2 in the same direction, the relative speed between them will be s1 minus s2, right? Now similarly here we have two hands, hour hand and minute hand, traveling in the same direction. So the relative speed of minute hand with respect to hour hand will be 6 minus 1 by 2, which is nothing but 12 minus 1, 11 by 2 degrees per minute. So the minute hand will be moving with a speed of 11 by 2 degrees per minute with respect to hour hand, right? So these are the basic things that you need to know to solve any question from clocks. Now let's move ahead and solve different types of questions that can be asked based on clocks. Now coming to the first type, What is the angle between the two hands of clock at 6:30? So at given time, you are asked to find the angle between two hands of the clock. Now we are indirectly asked to find the distance between two hands, right? So most of the students answer this question to be 0 degrees, which is wrong, right? 0 degrees is a trap here. Now I'll let you know why. Now let me assume this to be an analog clock. So let this be 6:12, and exactly at 6 o'clock, the hour hand will be coinciding with 6, and the minute hand, the longer hand, will be coinciding with 12, and the angle between these two hands exactly at 6 o'clock will be 180 degrees. Whereas at 6:30, right? So let this be 6:12. Okay, the minute hand will be exactly coinciding with 6, whereas the hour hand would have moved by some distance. Okay, if this is 7, the hour hand will be between 6 and 7. Now this is definitely not 0, and we are asked to find this angle. And I will be solving this question in two methods. First one using the concept of speed, time and distance, and second one using a simple formula. Right? Now coming to the first method. Now, instead of considering this question like this, let me consider that there are two persons, M and H, and the distance initially between these two persons be 180 meters. Okay, here the distance is in degrees, now the distance is in meters, right? Now the speed of H is 6 meters per minute, and let the speed of M be half meter per minute. Right? Now we are asked to find the distance between them after 30 minutes. Right? So this is the question, simple question. Now in these 30 minutes, okay, H would be traveling a distance of 6 into 30, which is nothing but 180 meters. Right? So the position of H after 30 minutes would be here. Right? So the initial position of M. Now, in these 30 minutes, M would have moved by half into 30, which is nothing but 15 meters. So, M will be somewhere here. And in these 30 minutes, the distance between these two persons will be 15 meters, which is nothing but the distance traveled by M in these 30 minutes. Right? Simple to understand. So, instead of two persons here, we have two hands of the clock. So, that's the only difference. The concept remains the same. Okay, so you can solve this question in this way, and the answer for this question should be 15 degrees, not 0 degrees. Right? Now coming to the shortcut. Now to find the angle between the two hands of a clock at any given time, we have a simple formula, and that angle is equal to mod 30h minus 11 by 2m. Right? Now if the given time is h hours m minutes, the angle between the two hands of a clock will be 30h minus 11 by 2m. So here we are given with 630. So the value of h becomes 6. So 30 into 6 minus the value of m becomes 30. So 11 by 2 into 30. So this is nothing but 15. 30 into 6, 180 degrees, minus 11 into 15, 165 degrees modulus. So this would be 15 degrees. Right? So you can answer these type of questions just by applying this shortcut. Now can you answer this question? What is the angle between both the hands of a clock at 10:20? Again, compare this with h hours m minutes. Angle will be equal to modulus of 30h minus 11 by 2m. Now, and this formula is also very easy to remember. Now 30 into 10 minus 11 by 2 into 20. Now this is nothing but 300 minus 110, which is nothing but 190 degrees. Now what if 190 degrees is not in the options? Now what if the options are option A 160 degrees, option B 170 degrees, option C 175 degrees, and option D 180 degrees. In that case, what should be your answer? Because you do not have 190 degrees in the options. Then your answer should be 170 degrees. Right? Now I will tell you why. Now, if I consider this clock, okay, so 10 will be here, 11 and 12. My apologies. Okay, consider this to be a clock. Now at 10:20, the position of hands will be somewhat like this. Okay, between 10 and 11. Now we have 190 as the angle between these two hands of a clock. Now that 190 degrees is nothing but this angle. Okay, now if an angle is more than 180 degrees, that's known as reflex angle. So if you get the angle to be more than 180 degrees, okay, all you need to do is you need to subtract that angle from 360 degrees. So this angle is 190, right? Now, but what if this is mentioned in the options? Now, how can we get this angle? Simple, 360 degrees minus 190 degrees, which should be 170 degrees. And that should be the answer for this question, right? Now moving ahead to next concept. Now, if you are asked for how many times do both the hands of a clock coincide in 1 hour, what will the answer be? Okay, in 1 hour, for how many times do both the hands of a clock coincide or together or overlap? Okay, now you will be having the clocks coinciding for one time in 1 hour. Right? Now let us consider any time between 1 o'clock and 2 o'clock. You will be having one between 1 o'clock and 2 o'clock where you have both the hands coinciding with each other. Now if that's the case, for how many times do both the hands of a clock coincide in 12 hours? 12 times, right? Now if the hands coincide for once in 1 hour, then they should be coinciding for 12 times in 12 hours, right? Logically that should be the case. Now but 12 is not the correct answer. 12 is wrong here. Okay, so the answer for this question should be 11 times. Now why is that one time less? Can you find out why? That's because between 11 o'clock and 1 o'clock, both the hands of a clock coincide for only once. Okay, so between 11 o'clock and 1 o'clock, you have both the hands of a clock together for only one time, and that too exactly at 12 o'clock. Now, so that's the reason you have both the hands of a clock coinciding for only 11 times in 12 hours. Right? Now, similarly, for how many times do both the hands of a clock be opposite in 1 hour? Now, what do I mean by opposite? Okay, so the angle between the two hands of a clock should be 180 degrees. Right? Now, if you consider any time between 1 o'clock and 2 o'clock, you will have one instance where you have both the hands of a clock opposite to each other. Right? Now, if that's the case, for how many times do both the hands of a clock be opposite in 12 hours? Again, that should be 12 times, right? But 12 again is the wrong answer. Okay, the answer for this question should be 11 again. Because between 5 o'clock and 7 o'clock, the two hands of a clock be opposite to each other for only once. And the two exactly at 6 o'clock. Right? So that's the reason you have only 11 times where both the hands of a clock be opposite in 12 hours. Now moving ahead to next question. For how many times do both the hands of a clock be in a straight line in 12 hours? The answer for this question should be 22 times. Now, when can we have two hands of a clock being in a straight line? Either the angle between them should be 0 degrees or 180 degrees. Now, when the angle is 0, can I say that they will be coinciding with each other? And in 12 hours, you have 11 such instances. And you have 11 instances where they are exactly opposite to each other. Okay, so 11 plus 11, you have a total of 22 times where the hands of a clock are in a straight line in 12 hours. Now moving ahead, for how many times do both the hands of a clock be perpendicular in 1 hour? Right? Now let me consider a time between 3 o'clock and 4 o'clock. Now if this is 3, 12, exactly at 3 o'clock, the hour hand will be coinciding with 3 and the minute hand will be coinciding with 12. And the angle between these two hands will be 90 degrees. Right? Now let me consider one more instance between 3 o'clock and 4 o'clock where the hour hand is in this position and minutes hand in this position where the angle between them is 90 degrees. Okay, so in 1 hour, you will be having two such instances where both the hands of a clock being perpendicular to each other, right? Now in 12 hours, they will be perpendicular for only 22 times. And again, there is a deficit of 2 times. If you know why, please mention that in the comments below. Now, if you find this video useful, please don't hesitate to click on the like button. For more videos of this kind, please subscribe to our channel, and you can share this video with your friends who are preparing for competitive exams. All right. Now, moving ahead to next concept. Now, at what time between 5 and 6 are the hands of a clock coincident? Right. Now, here we are given with the angle between the two hands of a clock, right, between 5 and 6, and we are now asked to find the exact time. Right. Now, when both the hands of a clock coincide, the angle between them will be 0. Right. So, we know that when the time is h hours and m minutes, the angle between them will be 30h minus 11 by 2m. Right. And we are given that this is 0 because they are coinciding with each other. Now, any time between 5 o'clock and 6 o'clock will be of the kind 5 hours and m minutes except at 6 o'clock. Okay, now if I ask you, tell me a time between 5 o'clock and 6 o'clock. Now the time will be around 5:10 or 5:15 or 5:20 or 5:59. 5:1 to 5:59 excluding 6. And we know that at 6 o'clock they are not coinciding with each other. Now we have a time in the form of 5 hours and m minutes where both the hands of a clock coincide with each other. So the value of h becomes 5 and we need to find the value of m. Now let me replace the value of h with 5. So this is equal to 30 into 5 minus 11 by 2m, and this is equal to 0. Now 30 into 5, 150. 150 should be equal to, if I remove the modulus and if I shift this 11 by 2m to the right hand side, you will be having 11 by 2m. Right? So m is nothing but 150 into 2, 300, 300 by 11. Right? So when the time is 5 hours and 300 by 11 minutes, you have both the hands of a clock coinciding with each other. Moving ahead to next question. At what time between 7 and 8 are the hands of a clock opposite to each other? Right? Again, we are given with the angle between both the hands of a clock. And the time should be between 7 o'clock and 8 o'clock. So the format of the time should be 7 hours and m minutes, because exactly at 8 o'clock, okay, the hands of a clock are not opposite to each other. Right? So we know that this is 30h minus 11 by 2m with a modulus. Right? And if they are opposite to each other, the angle between them should be 180 degrees. Right? Now let me replace h with 7. So 30 into 7 minus 11 by 2m, and this should be equal to 180 degrees. Now let's understand modulus here. Right? Now, for example, if you are given that mod x is equal to 5, what can be the value of x? Right? Now x can be 5, and also the value of x can be minus 5 as well. So when you apply modulus to any number, for example a, the outcome should be only the magnitude of a. Right? So there should not be any signs involved. So the outcome of modulus will always be positive. Right? Now for example, what will be the value of mod minus 4? This has to be 4 only, because modulus should always be positive. Right? Now if this is 180 degrees, right? Now if this value is 180, then modulus of 180 will be 180. And if this value is minus 180, then also when you apply modulus to minus 180, the outcome will be 180 only. Right? So the value of 30 into 7, which is 210 minus 11 by 2m, can be either 180 or 210 minus 11 by 2m can also be minus 180. So that when you apply modulus to these numbers, the outcome will always be 180. Right? Now if that's the case, 210 into 2, 420 minus 11m is equal to 360. And whereas here we have 420 minus 11m is equal to minus 360. Now let me shift this 11m to right hand side and 360 to left hand side. So if that's the case, 420 minus 360, which is 60, is equal to 11m, or this implies m is equal to 60 by 11. And 60 by 11, if I simplify this, this will be 5 by 11. Right? Now the time can be 7 hours, 5 by 11 minutes. Now let me consider the second scenario. Now if I shift 11m to right hand side, you will be having 11m is equal to 420 plus 360, which would be 780. Now in that case, m will be 780 by 11, which will be equal to 70 10 by 11. So the value of m can also be 70 10 by 11 minutes. The time becomes 7 hours, 70 10 by 11 minutes. Now, can we have 7 hours 70 minutes anywhere? No, because any hour will be having 60 minutes, right? So 770 10 by 11, this is not possible. So the answer for this question should be 7 hours 5 by 11 minutes. So that should be your answer. Now, moving ahead to next question. At what time between 3 and 4 are the hands of a clock perpendicular? Right? Now again, let me consider the time to be 3 hours m minutes, because exactly at 4 o'clock they are not perpendicular to each other. Now we are given that the angle between them is 90 degrees, 30h minus 11 by 2m. This is given to be 90, where the value of h is 3. So this implies 30 into 3, 90, 90 minus 11 by 2m. This should be 90 degrees. Right? Now if that's the case, when I remove modulus, you need to consider plus or minus 90. So in one case, you will be having 90 minus 11 by 2m is equal to 90, or in second case, you will be having 90 minus 11 by 2m is equal to minus 90. Right? Now in this case, I can cancel 90 and 90 on both left hand side and right hand side, and the value of m becomes 0. Whereas here, okay, after shifting this 11 by 2m to right hand side, we will be having 11 by 2m is equal to 90 plus 90, which is 180, and the value of m will be 360 by 11. Now this can further be simplified as 3, 32, 8 by 11 minutes. Right? So both the hands of a clock are perpendicular exactly at 3 o'clock, or 3, 32, 8 by 11 minutes. So if you observe, okay, in the previous two questions, you have only one definite time, because in 1 hour, you have both the hands of a clock being opposite to each other or coinciding with each other only for one time. Whereas in 1 hour, the two hands of a clock will be perpendicular for 2 times, and that's the reason you have 2 different timings here. So exactly at 3 o'clock and 3, 32, 8 by 11 minutes. Now moving ahead to next concept. Now to understand faulty clocks in a better way, let me consider 3 clocks, clocks 1, 2 and 3. Now clock 1 is perfectly fine. Now clocks 2 loses 2 minutes every hour. Right? Now loses means it runs slow. Whereas clock 3 gains 2 minutes every hour. Now if some clock is gaining time, that means it's running fast. Right? Now all these 3 clocks are set correctly at 9 a.m. someday. So exactly at 9 a.m. they are showing the correct time. Now this is perfectly fine. So after 1 hour, this clock will be showing 10 o'clock. Whereas this clock, which slows down by 2 minutes every hour, now this will be showing 9 hours 58 minutes only. Whereas this clock will be showing 10 hours 2 minutes. Now this is running slow, this is running fast. Okay, so losing time means running slow and gaining time means running fast. Right? Now similarly, at 11 o'clock, at exactly 11 o'clock, this will be showing 11 o'clock, because this is perfectly fine. Now whereas this will be showing 10:56 because it slows down by another 2 minutes, and this will be showing 11:04 because it gains 2 minutes in this 1 hour, right? And so on, so on, so on, right? Now if you are asked to find the time any clock would have lost or gained in n hours, that would be n into the rate of gaining time or the rate of losing time, right? For example, if you are asked to find the time difference between these two clocks after 12 hours, now I know that this is losing time, so minus 2 at the rate 2 minutes per hour into 12 hours, so that would be 24 minutes. Now that means after 12 hours, this clock would have slowed down by 24 minutes, and the time difference between these two clocks would be 24 minutes. Now similarly, the time difference between these two clocks would be 12 into plus 2 here, that would be plus 24. That means this is running faster by 24 minutes after 12 hours. For example, if the time in this watch is 9 p.m., then the time in this watch would be 8:36 and in this watch would be 9:24. Now if you are asked to find the time difference between these two clocks after 12 hours, all you need to do is 12 into, now you need to find the difference between these two rates. Okay, now this is plus 2 minus, okay, this one minus 2. Now minus of minus is plus, so 12 into 2 plus 2, which is nothing but 48 minutes. Now if you observe, after 12 hours, this will be showing 8:36 and this will be showing 9:24, and if you observe, the time difference will be 48 minutes. Now let me consider a scenario where you have two clocks and each of these clocks is gaining time. Now let this clock be gaining, let us say 2 minutes per hour, and let this clock be gaining 4 minutes per hour. Now if you are asked to find the time difference between the times in these two clocks after 24 hours, okay, that would be 24 into difference between these two, plus 4 minus of plus 2, which is nothing but 24 into 2, again 48 minutes. Now similarly, if you have two clocks both losing time, for example, let this be 1 minute per hour and let this be losing 4 minutes per hour, right? Now the difference between the times in these two clocks after, let us say, 12 hours will be minus 4 minus of minus 1. So 12 into minus 4 plus 1 minus 3, which is nothing but minus 36, but you cannot have minutes in negative. Okay, so just apply mod. Whenever you get a negative number, always consider the magnitude or the value of that number. So after applying modulus, you will be having 36 minutes. So the answer for this question should be 36 minutes. That would be the difference between the time shown by these two clocks. Now moving to another model on faulty clocks. Now a watch which loses uniformly was observed to be 4 minutes fast at 8 a.m. on Sunday. Now at 8 a.m. on Sunday, this watch is 4 minutes fast, so plus 4, and 2 minutes slow at 2 p.m. the next day, 2 minutes slow. Okay, so it was slowed down by 2 minutes at 2 p.m. on the next day, that is Monday. Now when did the watch show the correct time? Now how many hours do we have from 8 a.m. on Sunday to 2 p.m. on Monday? Okay, now from 8 a.m. on Sunday to 8 a.m. on Monday, you have 24 hours. Plus, now from 8 a.m. on Monday to 12 p.m. on Monday, you have 4 hours. Plus, from 12 p.m. on Monday to 2 p.m. on Monday, you have 2 hours. So 24 plus 4, 28 plus 2, 30. Right? So in a total of 30 hours, this clock slowed down by 6 minutes. From plus 4, it has now come to minus 2. Alright, so it was slowed down by 6 minutes. Now, if it is slowing down by 6 minutes in 30 hours, now its rate of slowing down would be 1 minute in 5 hours. Okay, it would have slowed down by 1 minute in 5 hours. Now what was asked? When did the watch show the correct time? Now when can we have the watch showing the correct time? When it slowed down by 4 minutes. Okay, so this plus 4 has to get nullified. Now it is slowing down by 1 minute in every 5 hours. Now to slow down by 4 minutes, this will be taking 20 hours. So after 20 hours, this watch will be slowed down by 4 minutes, and at that point, this watch will be showing the correct time, right? Now 20 hours from 8 a.m. Now from 8 a.m. to 8 p.m., you have a total of 12 hours plus 8 p.m. to 12 a.m. you have 4 hours plus we have remaining 4 hours, so 12 a.m. to 4 a.m. Okay, so this completes 20 hours. Okay, so 4 a.m. on Monday should be the correct answer. Now coming to the last model from faulty clocks. Now a faulty clock loses 1 minute every day and is set at the correct time today at 9 a.m. Now after how many days will it show the correct time again? Now we have a clock which loses 1 minute every day, right? And that was set at correct time today at 9 a.m. We are asked to find after how many days will it show the correct time again. Now when can a faulty clock which is losing time at a uniform rate, okay, can be showing the correct time again? Now the logic is simple. Now that has to be slowed down by 12 hours, right? Now for any faulty clock, either it's gaining time or losing time at uniform rate. In order to show the correct time again, either it has to lose 12 hours or it has to gain 12 hours, right? Now this clock is losing 1 minute per day, right? Now 12 hours, which is nothing but 12 into 60 minutes, which is nothing but 720 minutes. Now to slow down by 720 minutes, that will take 720 days. So the answer for this question should be 720. Now these are some of the important models from which you can expect questions based on clocks. Now if you find this video useful, please like this video, and for more videos of this kind, please subscribe to Apex channel. And if you want any detailed video on any topic in logical reasoning, please let us know in the comments below. So thank you guys. We'll see you guys in the next video.